Hi, welcome to this quick how to help video on functions. What we're going to do is just address all the techniques that this topic has within it. I'm using two questions to help with that. You can see the red brackets. They are the marks that were assigned to these particular questions. If you are really on this video just to see a specific thing, then do by all means jump to that. If you just want a good roundup of all the techniques that we use in functions, just watch through and we will cover absolutely everything. Okay, so the first one is usually the first question on the exam paper, and it really is nothing more than substitution. If we've got the function f of x equaling 2 over x squared, and they say find f minus 5, what they've done is change this x to minus 5. So when we write out the function, we're going to change the x to minus 5. Now, good practice is to put that in brackets because it's negative. All right, and we don't want to get in a muddle over our negatives and then end up going wrong. The answer is going to be 2 minus 5 times minus 5 is positive 25. And that's your answer. So that's why it's 1 mark. It's generally a straightforward substitution question. The second question is where things start to ramp up, okay? What they're asking when they have got the functions of f and g combined, and in this instance, they're telling us to use the number 1 as our starting point for this question. But what they're actually doing, or certainly the way that I think of it, is I think, right, I've got my function of x that's mentioned first in the question, and this is dropping into it. So I always see the first letter that's given to me, and then the second letter drops in. It's quite a nice way of thinking about it. Well, I can't drop G1 in until I have found G1. So that's task number 1. If I've got, let's rewrite it here. If I've got Gx equals 4x cubed, and I'm changing the x to 1, then my x is going to change to 1. And obviously, that is perfectly acceptable. How you write that is down to you. That's going to give me 4. The result of G1 is 4. Therefore, 4 is going into the function of f. So I've got 2 over 4 squared. That is going to give me 2 over 16, which will simplify to an 8th. Let's take a look at the next question. What we've got here is an inverse question and an equations with composite functions. So it's pretty full on, that second one. And you know it is because it's 5 marks. So let's look at the inverse and the technique for this. When the function's fairly straightforward, if you're quite confident with reversing everything, which is what inverse is doing, it's going to do the opposite. It's going to do the opposite signs. It's going to reverse the operations in the order that they were done in. And if it's a fairly straightforward one and you're confident with that, you probably will muddle through and do okay. But if they start to get complicated, it's very easy to lose how it's coming together. So just learn a technique that works regardless of what you've been given is my advice. And this is how we're going to do our inverse functions. So we're doing f of x equals 3x minus 1. And we want to find the inverse. Okay. What we're going to do is set the f of x to y. That's normal for us to see. We're then going to swap the variables. If we swap the variables and then rearrange to get y back on its own, that rearrangement is going to create the inverse. So we're going to take the minus 1. X is already there. It will land as plus 1, leaving me 3y. We're going to take the 3 and divide through by it. So our function x plus 1 divided by 3. Now, if they are quite complicated, this technique is a dream. It really does work. If you're not so great at your rearranging of formulae, obviously there is a video that you could watch, but just remember to apply your BIDMAS backwards, okay? We had a subtraction, so we moved it first. We had a multiply, so we moved it second. You can only move an operation if it's entirely on its own. So if, for example, I had x plus 3 inside a square root, BIDMAS backwards is suggesting to move this. You can't get to it, you can't touch it, because the 3 might have that add attached, but it's also got the root attached. You can never move anything that's got 2 operations acting on it, okay? All right, let's get on to the big one. We've got the function of fgx equaling 2gfx. So we've got 2 composite functions and one is getting doubled. And we got to show that as we work through the maths that this creates, it's going to give us 15x squared minus 12x minus 1. Now, there is a lot happening here. We're going to break it up and work it one thing at a time, okay? So let's look at our fgx. This tells me I've got the function of x and I'm dropping g of x into it. Now, g of x is x squared plus 4. So I'm dropping the algebraic expression in. I'm not putting a value, finding a result, and putting that in, and putting the algebra in. That means that wherever there is an x in the f function, it is going to change to all of this. So the function is 3, and then it's x. But I've got to do all of x squared plus 4. And then we've got minus 1. So my x in the f function has been replaced by the expression in the g function. I'm going to expand this. And it's going to give me 3x squared plus 12. And I've got my minus 1 on the end. And tidy it up, gives me 3x squared plus 11. I've now got to do it the other way round. I've got 2 lots of g f of x. So this time I've got my g function. I'm dropping in the x function, and I'm going to write that wherever there's an x. So the function of g is x squared. So I've got 3x minus 1 all squared plus 4. And I mustn't forget, and it will be really easy to do, I mustn't forget that whatever result I end up with will need to be doubled. Okay, so let's concentrate on what we've got going on here. If we expand our 3x minus 1, crab's claw, foil, whatever method you use, we would end up with 9x squared minus 6x plus 1 plus that 4 on the end. That tidies up to 9x squared minus 6x plus 5. I've then got to times everything by 2 because I want double that function. And I will end up with 18x squared minus 12x plus 10. This is telling me to set them to equal each other. I've now got 3x squared plus 11 equaling 18x squared minus 12x plus 10. I am going to move this across to this side. It will leave nothing there, which means it will be a 0. Obviously, I want to do that because I need it to equal 0. My 3x squared will come across and it's going to land as minus. What I'm doing is I'm moving a positive number that I do not know, so it's landing as a negative number I do not know. I'm obviously going to move that positive 11 as well, and that's going to land as minus 11. 18 take 3 is 15x squared. Still got my minus 12x. 10 take 11 is minus 1. I have got 15x squared minus 12x minus 1 equaling 0. Job done. Hopefully you have found this really helpful. These techniques don't change. Obviously the questions will change, but the steps in the way that you move your way through will always be the same. Thank you for joining us on this Target Maths video. Really do hope you have found it helpful.